This lecture deals with data, hypotheses, testing, basically trying to give us some level of confidence in what we're saying as scientists. So right off the bat, you can talk about the different types of data. And in geology and paleontology for our class, we use all of these at different times for different particular problems. So there's nominal data, data that has names. So if you just name a species of fossil, Productus johnsoni, something like that. Categorize it as male, female, its color, etc. That's nominal data. Then that nominal data can then be counted. So you can count, say, the number of males and number of females you have. But first classifying it, that's just giving it a name or a nominal. Then there is ordinal data. Ordinal data is also used quite a bit in geology and paleontology because it's data that can be placed in a particular order, ascending or descending, as it says there, it lists particle size, but this could also relate to a lot of different factors that are typically taken as data for fossils. There is interval data. This is particularly true for geology and paleontology and other disciplines like ecology, where you have dates or data with no true zero. So for instance, there's some example right there of actual dates, things that could be related to human terms. But of course, in geology, we could talk about something that is Cambrian versus Ordovician versus Jurassic versus Pleistocene. And then there is ratio data, which is most numerical data. This is something that has a true zero. So there's counting of things, as well as numerical measures. This is probably the area that we would use the most in paleontology. And then, of course, you can also take any one of these particular measures and manipulate them in some other way. Divide length by mass, divide density by counts, etc., etc. Just a couple of quick quotes on the importance of data by some biggies in science, Richard Feynman, and then, of course, Lord Kelvin. If you haven't measured it, you don't know what you're talking about. Well, once you have data, or at least some grasp of the data that you're going to get, you need to cast about hypotheses. And a hypothesis, as it says there, it's just a statement or a guess or an idea, or somewhere you make a statement regarding what you think you're going to find. Actually, it's usually what you think is going to be the opposite of your typical guess. We call that the null hypothesis. And for just a few examples here, notice they're framed as no difference or no relation or you're equal to. So there's no relation between this lava and that lava. There's no relation between this or that. Or these two things are equal. Therefore, there is no difference. So another example, a null hypothesis. You could say there is no difference between the average number of streams per square kilometer in the bedrock type, and then the alternate hypothesis has to be the opposite of that, where you would say, aha, there is a difference. So the null is saying that you're going to find no difference when you examine data, and then if you do, you have to falsify that null hypothesis. It doesn't mean necessarily that you're accepting the alternative hypothesis. It means that the alternative hypothesis may be true. For a lot of the types of hypotheses that are made typically in paleontology, you just have to make some observations, and that would falsify your null hypothesis, or not falsify it. But for many things, we need to talk about statistical significance. And so significance is saying, what is the point at which I am going to reject that null hypothesis and accept that that alternative hypothesis may be true. Now, this is usually in the realm of statistics, and so we talk about the probability of it occurring. Now, I know a lot of you have not had statistics, but just a quick and dirty introduction to the subject here. You're going to talk about the probability of a particular result being less than 1 in 20 or less than 1 in 100. We look for the magic p-values of 0.05, 0.01. If you're not entirely sure about this or you haven't had statistics, well, don't worry about it. Past will correct this for you, I guess, or lead you the right way. So you'll spit out a p-value, and if it is greater or less than a particular p-value, it'll let you know if you are going to falsify that null hypothesis. Now, we always want to avoid decision errors. Now, this is something I'm not going to worry about so much for this class, but I wanted to at least throw these slides in here. We have two types of errors that you might make. So you could have a type 1 error where you reject the null hypothesis even though it might be true. Usually then you would have many more trials or many more data added, and that tends to make that possibility less likely. Another type of error, which we call the type 2 error, is to accept a null hypothesis, basically not reject it, even though it is false. So you usually see these little sort of Punnett square diagrams here where you don't see anything significant, nothing is there. You have these two quadrants where you are right, and then you have the two quadrants where you are wrong. Generally, for most of the tests that are going to be done in paleontology, and especially in this class, we don't have to worry about type 1 and type 2 errors. We are going to either soundly reject our null hypothesis or soundly not be able to, and so we should be fine this way. And then just another diagram showing the same sets of possibilities, two corrects, two types of negatives. This last little bit is again, it's just a shockingly small introduction to a vast subject. If none of you have had, or if you have not had a statistics course, I strongly recommend that you have such a thing. One of the things that you're always going to be looking at for statistics is what test to use. What are you going to use to determine your significance? So you'll typically set up a null hypothesis of the type this equals that, and then if you see a difference, well, it can either be a significant difference or a not significant difference at a certain level, and so you choose different test statistics without even knowing the actual sort of mechanics of the process. Past will spit out things and let you know that things are falsified. So the rest of this is just going on like this, and so it'll tell you when you need to reject or accept an alternative hypothesis. Again, I'm sorry for such a brief introduction to the test significance part of this, but I wanted to make sure that you got at least a brief introduction to data types and then hypothesis setting up and hypothesis testing.